Hello everyone, and today we have a very important topic to discuss. Today, I will be focusing on the firmware software supply chain security and its complications, but all the challenges I will be discussing in this presentation applies broadly to the software supply chain in general. Why I'm here and how I'm connected to the software supply chain security. I'm Alex Matrosov, I'm founder and CEO at Binarly. I spent 2+ decades in hardware and firmware security industry, where I've been focusing on the different shades of the supply chain, including CPUs, GPUs, data centers, and many other things. Today, I want to spend my time discussing all these complications and why it is important. As you probably all knew, the software supply chain is one of the biggest challenges in the industry, and we're facing currently the time when the complexity of the software overgrow our pace to handle all these problems and vulnerabilities. Most of the solutions we currently see on the market, they're creating alert fatigue problem. If you just chat with any product security team, they will be definitely say, if you give me another 100 alert, we don't have capacity to deal with them. How we should handle such problems? This is a very good question, but unfortunately, forecast of growing numbers of CVEs we are receiving from the vendors, from the researchers, from the entire ecosystem don't give us very optimistic view what will happen in the near future. And if you think about, we currently facing the time when we are rethinking how the software will be developed in future. So artificial intelligence will be actually produce way faster the new types of the software, and that will be increase the complexity, but also the time for delivering the software will be faster. Problem with that, AI assistants making a lot of security mistakes, and we already seen this multiple times. I think we need to understand how firmware supply chain security handle it now and what we should change to keep the pace with this problem in future. If you think about the problem in general, we are looking always to the source code, and all the static analysis we currently see in the industry, they are not really doing good on the source code analysis from the perspective of very complex problems and actually complexity of the computation with the pointers in languages like C, C++, and others, where some item can become any other type during this journey in runtime, and we just don't have an ability on the source code level to track and contain such problems. It's just a Turing complete problem, which is very hard to solve. What is missing, it is our ability to look into the binary and do the binary analysis to understand what we are shipping to the customers. Also, supply chain is always complicated because we not only have single developer to develop the entire package of the software which we are shipping to our customers. It's always connects to many dependencies which has come from the third party, and it can be open source libraries, it can be third parties SDK and components which is actually not come with open source, and you have a binary blob you should trust, and you don't have much ability to understand what is inside. And it is exactly what's happening with the current solutions, which is like old 90s antiviruses, which is hashing the module and matching this hash to the known vulnerabilities related to such particular module or the software package, or the version, taking the version of the package and map to national vulnerability database to connect all the CVEs. But such approach is just creating significant alert fatigue problem. And this doesn't give us much capacity to actually deal with all the complexity coming our way in the near future with velocity of artificial intelligence and ability to develop in the software. If you think about, we need to make a shift left, not only to understand the source code we are developing, but after the compilation and build time, to understand what is inside of the software package and actually the binary and what we are shipping to our customers, because this is a very important moment where you can understand and see everything in the single place and location. And I think like Binarly, being one of the companies which spend a lot of time on committing to research, we actually built the biggest in the industry knowledge base about firmware vulnerabilities, specifically in UEFI-based firmwares. And it's mainly open in our advisories, in our proof of concepts and detection rules called Firmware Hunt. If you think about the firmware, it's very foundational for modern infrastructure. Firmware, it's actually foundation for the entire compute stack we're dealing with right now. And if the firmware is broken, it's very hard to deal with confidential computing and protect what is go on top of the firmware and operating system, of course, but modern cloud stack as well. And I think this is why we should pay way more attention to the firmware security, and software supply chain in general connects to the firmware space too. Software risk management nowadays, when it comes to the proprietary components, which is not contained in the source code, it's usually use the software which is being developed like in early 2000s or before 2020, when we don't have velocity with artificial intelligence on developing the software. And now we need to really rethink how this approach works, and just searching for specific byte sequences, it's not enough. We need to understand better the code. We need to classify the nature of this code semantics, and actually give the guidance how these problems can be fixed, and be more agile to not detecting of known vulnerabilities, but also unknown ones. And of course, we're facing these interesting times when all the big companies and US government focus to innovate the industry and give the stage of rethinking how we are doing the binary analysis through the prism of artificial intelligence and modern technologies. So I think we are living in very interesting times, but let's focus on the firmware security. Why we can talk about all this complexity with confidence? Because our company actually disclosed a lot of vulnerabilities for all vendors you can find on the market. Basically, entire industry been affected by many disclosures we did over last 2 years. And we disclosed about 462 vulnerabilities in the past, and this number is just growing every day. And why we did that? This is actually validation our approach and solution really works. If you think about and look for this specifically demo, we created this demo to show you how our tooling is working, and it's identifying the problem, which is completely unknown. It's a new vulnerability being found on one of the firmware vendors' firmware package. And what we are seeing here, like Binarly platform runs the testing for known class of the problems, but finding the invariance of this problem, and this problem being unknown. It's basically 0 days. And it's help our customers to be more proactive to mitigate such attack vectors before the attackers will do that. And this is how it's working behind the dashboard. I just want to give you some taste about binary technology stack. But also I want to talk about these two examples of vulnerability disclosure we did last year. One of them is Intel BootGuard leaked keys through MSI data breach, when these keys from the BootGuard, we've been thinking initially connects to only one vendor, but unfortunately it's been reused by the entire industry, and we find out it's been used in many different vendors' firmware, and only binary technology can find these dependencies and validate them, because in many cases some of the vendors saying these keys are not related to their firmware and they just stored inside the package but not used. But binary technology not only finding the crypto materials, it's validating if it is used in the code or actual secure boot scheme using validation with these specific keys connects to the BootGuard and other technologies. Another vulnerability which is also validate our approach on thinking and innovating the industry with completely shift-left approach in vulnerability detection, it is a log fail. And log fail, it's not a single vulnerability, it actually connects so many different cases across the entire industry. And if you think about, it is impacting so many different things. It is impacting reference code which comes to every single firmware package in the industry. It's not only impacting Intel or AMD, it's also impacting ARM-based computers, which is used UEFI firmware. And of course, it's impacting all shades of different independent BIOS developers, IBVs, like American Megatrends, Insight, and Phoenix. Unfortunately, in many cases, this vulnerability disclosure being handled very poorly, and some of IBVs, or most of them, assign only single CVE to log file. What that means when you're assigning single CVE for 20 different vulnerabilities? Of course, most of them will be stay unfixed almost forever, and it's exactly what we are seeing right now. But also, why is the log fail? It's so interesting case to show the complexity and impact of on the supply chain. I think the log fail, it's one of the most impactful vulnerabilities which is being happening in near term. And of course, like everyone last year been freaking out about Black Lotus and some others boot time vulnerabilities, but impact from the log fail, it's way more impactful because it's very easy to exploit from the operating system layer. And then it's not only bypassing the secure boot scheme, it's also allow you to execute the code during the DXY phase and boot time on the firmware layer. The attack surface for image parsers inside the firmware is huge. And if you think about it, connects so many different components and the vendors in that space. And logo fail, it's actually very interesting attack when the logo is changing on the file system and then it's impacting the firmware during returning from or rebooting the machine with a new logo. What's happening at this time, logo image, it starts parsed by the firmware parser for this image. And what we figured out, most of the parsers which the industry been using, it's so vulnerable. But not only that, many vendors like Phoenix been using very outdated components and libraries. How come as an industry we talking about software supply chain security for years, and then foundational component like firmware being impacted by so obvious vulnerabilities? And we don't use something like significant new to find these vulnerabilities. We use the fuzzing approaches, and some of them been detected through our platform, which has caused initial interest from us to look through these problems more precisely and in more detail. But if you think about, we found the hundreds of root causes for the crashes during our fuzzing sessions, and this is super interesting case when you can showcase so much impact on the firmware without actually reinventing new attack vector or attack surface. It just exists for years. And the question is, why the vendors who develop in the firmware never fuzz their firmwares or use so poorly set of practices for product security? This is a very good question, and unfortunately I don't have an answer, but put a bit more color on the problem. The logo is not protected by BootGuard and can be easily changed on the firmware image. What that means, it's not only the attack from the operating system layer, it's also tampering attack when someone can just reprogram this logo on the firmware storage itself, and then it can deliver continuously malformed a piece of malware implanted into the firmware and will be continuously delivering. We found 29 unique root causes, and 15 of them very likely can be exploitable, and we validate all of them. Actually, we found most of them are exploitable. Let's look on the demo of Logofail and see how this attack vector can trigger the vulnerability and actually impacting the operating system. And we're not talking about some outdated version of operating system. It's the most recent Windows 11 with very new hardware from Lenovo. Yes, Logofail is very interesting case, and it's gained a lot of attention, but also show how we're not paying enough attention to the firmware supply chain in general. Logofail, it's, as you can see, it's very interesting case and very impactful vulnerability. Also shows how software supply chain in the firmware world are actually not keeping the pace with the problems and the industry attention to all of these problems as well. This particular vulnerability, it's been one of the most impactful vulnerabilities actually binarily ever disclosed, because it's been affecting so many devices, and even after 400 days of Logofail disclosure, we are already see how it's playing a negative role and handled poorly with obscure ways how actually vendors fixing these vulnerabilities. As example, one CVE for multiple vulnerabilities will be never end up well in the ecosystem, specifically if it is applies to the entire supply chain. And we want to thank you, CertCC, for helping us to handle this massive disclosure. It's been a pleasure to working with them, and I don't think without their help it will get so smoothly. Of course, binary products detecting all these problems, and more importantly, we have a unique approach, not just like a checking the version and map CVEs, which is vendors claim, because they can say we fix one, but because it's 15 vulnerabilities, you don't know really if they fix all of them or fix only one. But CVE will be relevant, right? And they indeed can fix one and say they fix this CVE, but another 14 vulnerabilities can persist in these particular cases. And binarily going through the deep code analysis to understand if this particular vulnerability is actually still unfixed and exists on the particular software package. It's why it's make us different, and as you can see on this screenshot, we can detect the code related to the vulnerable code trigger, and it's make it way bigger difference compared to any other solutions on the market. Binarily really closing detect, analyze, fix loop, and we're helping enterprises but also device makers and software makers to understand better their software supply chain, and it's exactly why we call our platform binarily software supply chain transparency platform. Diving deeper, we actually not only helping to detect the problem, we're helping to understand better the nature of the fix. If you think about majority of the current delays on the fixing vulnerabilities, it connects to understanding of the software developer of the problem itself, and then start to understand how to work on the fix. And we have developed an AI assistant which is helping to understand the problem and fix the problem and generate actual potential candidate to fixing this problem. And just think about, we don't have any access to the source code. It's completely made up only from the binary analysis. And this is actually creating significant difference. Without any access to the source code, we can understand the problem, we can help you to fix and contextualize what's happening and how this problem is impactful and how you can fix it and remediating it. This is why we created binarily transparency platform and helping to the entire ecosystem to recover from all these repeatable failures. Also, it's very important to remember the software supply chain complexity will be not go away, and we will be facing it for the next generation of the software developers evolution, and the platforms they will be developed, and many other ways and different shades of it. But what also we should remember, the defensive software also need to be innovative and innovating together with all this growth of the problem. And I think we all understand this complexity. It will be not solved itself. As an industry, we need to rethink and understand better what software we are using, how many dependencies the software contain, and how much information and contextualization we understand about them. This is a huge difference between having the package and have only the top core component version, which is we can understand how many vulnerabilities related to them, or we can X-ray this package and understand all the transitive dependencies, all statically linked code, and everything what is going on there inside the package. This creates a huge difference. It's like an X-ray and the doctor in one package to analyze these results after you getting them. Thank you for your attention, and if you're interested about these problems, let's chat.